So theoretically, I have improved the audio ducking so that when I start talking, the background music should just go away automatically. And it seems like that's going to work. Unless it's just because it was in the quiet part of the music. Oh well. We shall see. Technology marches on. Hey folks, it's T2sday update 3123. These were the goals for this time. I'm going to provide results in this order, but first, let's take a look at the opening video. This is a little bit hard to see what's coming up here as it goes up, but slowed it down right there. The periphery detected that it reached the edge of the universe, and it's sending a signal back up. That's that red line going down back to the root, saying contact warning, don't keep going in this direction. And in fact, the root picked a direction that went some other way. So I started up another one, and this one is bopping around, and that's basically what we've got in this video. Whoops. Oh, there was more. Oh, poop. We missed it. There was one bit at the end there that showed a sort of a speed comparison between HCV12, what we saw 2 weeks ago, and this one. And it's a lot faster for reasons that I will explain in a second, because that's what we're going to do first here. We've been looking for large object motion for the last couple of weeks, or the last couple of decades, depending on how you look at it. And HC3 is the latest evolution in that. I said last time that I felt it had a lot of potential. I still think it has a lot of potential, so we'll see. All right, so the improvements this time, what we saw in the opening video, V13, in the original HC12 that we saw last, HC3 version 12 that we saw last time, the root would issue a signal saying, I want to move west. And that would propagate all the way out to the periphery, and then the periphery would respond all the way back up saying, we've moved. And the root would not issue another motion command until that had gotten all the way to the periphery and all the way back. But now we have pipelined motion that, the feeling was I looked at it, is that, after the root moves, everybody rustle all its, entourage all immediately rearrange themselves to try to realign on the root. And once it's gotten 3 or 4 layers all realigned, it really kind of seems like it ought to be able to go ahead and move again. That's what we have going now. And it's a little difficult to see in that one, but you get the idea that there's these waves. And if it's a big thing, and this particular pipeline, it's a four-stage pipeline. So once the root sees four layers all the way out, which it can't see them, it has to rely on them reporting back up, that they're all aligned, it can go ahead and move again. And in the size of the 20 diameter big guys that we've been doing, that's like three motions in one, all going. And so it can go a lot faster. The flip side of that is that if there's an obstacle out there, and the periphery has just noticed, hey, there's something we're about to run into, stop. There might be three more motion commands in the pipeline laid out, and that can cause trouble. And I think the deadlock that happened in the demo video is related to some of that. I'm not sure. So we have pipeline motion. It's a trade-off. You can get more speed, a little more risk. In addition, we have this peripheral edge detection, that when a motion arrives at the periphery, not only do they move, now they look around and say, can I see anything? And they report back contact warnings. Have we reached the edge of the universe? Have we reached other things that are not empty? Send that back to root, help it decide. So that's what's working, and it really increases the amount of objectiness, the amount of cellness that the HC3 grid has. And finally, I've changed its name. It's not an HC3 grid anymore, primarily because grid is super overloaded in T2 land. I'm calling it a diamond because that's what it looks like. So an HC3 diamond, what we have is moving diamonds. We're going to make more complicated diamonds. We're heading for living diamonds soon. All right, so I want to take a couple of minutes. I hope this doesn't go too long. I've got a couple of more. I've got some more video of HC3 version 13, I think it is, running in the simulator. But I don't want to take the time to show it now, so I'll show it in the live stream afterwards. And if people really want to see it, they can go find the live stream, or else it's just sort of optional extra bonus material for the live stream folks. But I wanted to talk about this idea of spatial recursion, because to me, it seems like it's more foundational, more fundamental, more important than I see the computer science and computing field acknowledging. And so, all right, so recursion in computer science is one of these things that once you get it, it's the most beautiful, obvious thing, and you cannot unsee it. It's to me the poster child of once you get it, you once you see it, you can't unsee it, and it becomes very difficult for you to imagine how hard it used to be before you actually got it. And in fact, I was just having a discussion on Twitter a couple of days ago about trying to put in a good word for no, recursion is not obvious until you get it. I think it's possible that the spatial recursion that I'm going to talk about may be helpful in that regard. But the key object of recursion is you define something in terms of itself. And that sounds just silly on the face of it. What is a towel? It's a thing that acts like a towel. That's obviously done no good at all. The key in computer science recursion that makes it work is you have to have two cases. You have to have partly a definition that doesn't involve itself and another part that does. So you say a linked list consists of a head element plus a linked list. That's a classic recursive definition. A tree consists of a root plus two subtrees and so on, plus two more trees. In the traditional approach in computer science, because of course we're using RAM and pointers and all that stuff, we've lost space. Spatial recursion is not usually spatial. It's usually abstract. And I think that's one reason why it's hard for people to get their head around it. And if it was laid out in space, it might make more sense. And so the bucket brigade algorithm, well, bucket brigade in real life, I'm not necessarily talking about it, it's a specific thing called bucket brigade algorithm. Where you're trying to build a wall to hold back the levee, and you've got a big pile of sand and bags over here, and you've got water leaking over there. And so you have this algorithm that, if you're next to the sand, you fill a bag with sand, and you hand it to the next person who's heading towards the levee. And they walk until they run into somebody whose hands are empty. They hand them the bag and then head back for another one. And it goes all the way, moves all the way back until it gets to the other end, and they toss it on the wall that they're building. So in that case, we have sort of two base cases. We have if you're next to the sand pile, you do this. If you're next to the wall that's built, you do that. Otherwise, you do you look to your right, find a bag you can pick up. Look to your left, find empty hands you can hand it to, and just do it over and over again. And everybody in the bucket brigade does that same algorithm, and the wall happens. And it's incredibly robust. It's self-stabilizing in a lot of ways. And, you know, I think there's a lot more mileage in it than we haven't seen. In computer architecture, there's things called systolic arrays, which were big when I was in grad school in like the 80s. The research was originally done. Now they're back, and there's like tensor processing units and all that sort of thing. So there is a certain amount of spatial recursive thinking, but it's still very limited and rigid and top down and so forth. I think there's more to it. So in general, it seems to me that there's relationships between our data members and theirs. So, you know, I am a hard cell 3 atom. I look out to my neighborhood. I see another hard cell 3 atom. Well, hey, you're like me. You have the same data members I do. I have a data member called hop count. You have a data member called hop count. What should we do about it? And depending on what you do about it, you get all of these different behaviors. And so, for example, if there's, you know, my data member and your data member, we could swap them. That would be something we could do. And what you get is some kind of crazy diffusive stuff where nothing actually gets created or lost. It just gets shuffled around. We could say, you know, just copy whatever they've got or copy ours to them. And a bunch of other things. I've got a quick demo in the simulator. Okay, so let's, all right, this is swap. Okay, so here we've got a bunch of sites, whatever, they're looking at random neighbors and they're just swapping with whatever the neighbor has got. And, you know, it basically looks like random stuff, which is fine. That's what it is. We could do something more like this, where we copy. We look at a neighbor just at random pick, random neighbor, and copy whatever there is. And we get a very different behavior. It's still kind of random and churning, but, you know, there's a kind of a rich get richer sort of thing. And eventually, if we let this thing go long enough, which I'm not going to do, we'll get one color will dominate, and it'll be winner take all, because once there's only one color there, there's no way for any more colors to come in. We'll just be copying the same color back and forth. And finally, there's the, where it is, all right, this one. Where we're going to do counting off. Now, in order to count off, you know, you say count off from the left, you know, is my horror show from, you know, gym class getting picked for things. Actually, you know, counting off was better because my choice would come up on the basis of a number rather than the basis of the captain not wanting me. All right, but so we need a root. We need a beginning to count off from, so we have a root. We plop the root down, and then everybody counts off from the root. This is the hop count idea that HC3, hard cell 3, is using. This is how it tells. It does count off from the root until you get to a certain level, and then you stop, and that's the size of the thing. And again, this is all very robust, and if we add more stuff, it just, whoops, I did a bad thing. I created a whole bunch more roots. I meant to create a whole bunch more growable stuff, but it doesn't really know. All right, so here's some more growable stuff instead. And why is that not doing anything? There we go. So now we've got, and what the heck, we could put multiple roots in here if we wanted. If we make another little root here, say, now this thing has two roots in it, and what's going to happen? Well, everybody's going to look to their nearer, whatever it is, kind of root. They're going to figure it out. Does that make sense? Maybe it does, maybe it doesn't. Once we decide that we're going to have a privileged upstream, a privileged root, then it's on us. You know, we picked that, so it's on us to say, well, what if there's two of them? You say, well, there's not supposed to be two of them. Yeah, well, what if there are? Something will happen. So we still haven't settled in the thing. All right, so, whoops, where do we go here? Oh, here we are. So really, from one point of view, the swap, diffusion case, and the copy winner take all thing aren't really recursions in the computer science sense because they don't have a clear base case. But the counting off totally does because we have a root. And similarly, you can do many other things. You can do like, just copy whatever it is upstream or broadcast whatever it is to everybody downstream. And that's how the pipelined alignment depth is working in HC3 version 13. It's counting off how many layers are aligned and reporting that back up so that when the root or even somebody further down says, okay, there's 5, 3, 4 layers, whatever it is, that are all aligned with me downstream, that means I can go ahead and take the next step to get me closer to what upstream wants. This extends to MapReduce. There's bunches of regular sort of spatial parallel computing stuff in computer science that this is closely related to. But it seems to me that there's room for a new language here, where you'd have a language of data members that are being combined and shared amongst members of their own kind or members of other kinds as well. And you would just have these little equations basically saying how they should update. This should be the max of everybody else. This should be the min of everybody else. This should be a copy of the highest priority one, and so on. Because I feel like as I write, particularly these HC3 things, where now I'm sending contact warnings up while I'm sending motions down, that I'm writing the same kinds of code over and over and over again that could really be simplified with some tiny little equation-y type language. We'll see. If anyone wants to think about that, I want to think about that too. So how it works in the new steps. So I talked last time about how HC3 89% empty because it has that 3 by 3 grid is the repeating pattern of which there's 1 occupied and 8 empty. But part of those empty ones, 1, 2, 3, and 4, those we kind of need to keep empty so that the center guy, the root, the center being, has an option to move east, west, north, or south, 1, 2, 3, or 4. But that means there's still these pockets, 2 by 2 pockets that are completely unspoken for in the basic HC3 processing. And I wanted to start speaking for them. Because in particular, I want to be able to have this HC3 moving like it's doing. It's moving great, but wanted to be able to have content living inside the grid. That, very general. We don't have to know what it is. We may put some rules on it, some instructions on how to live successfully in a HC3 diamond. But other than that, we don't care. And we're just going to do what we do. And if they don't like it, they can lump it. So the problem with saying those 4 pocket sites are available is that they're not always available. And so, in fact, if our center just decided to move up because it wanted to move north, because it's a root decided it wanted to move north, well, now these pockets, there's only 1 by 2s, whereas these bottom ones have become 2 by 3s. And that's going to continue to be the case until this one moves up and restores the bottom pocket, or this one moves up and cuts away the excess in the bottom. Okay. But what if there was stuff there? What if before the move there were a couple of atoms over here, a couple more atoms over there that we want to carry along? How are we going to do it? I struggle with this several different ways, and the plan is this. The plan is we're just going to move it. We're going to rearrange the contents of the pocket to make it make sense. So in this case, we want to move this blue one up. We want to move this orange one up. We need to move this red one up so that the drive-in lane is clear going out, and we work it all through, and it comes out like this. The blue one goes up, the pink one gets pushed into a whole nother column, and the red one, which had been down here, gets moved up so that we still have a clear path on the axes of the HC3 itself. And the idea is that if you want to live in HC3 pockets, you need to be okay with that. And that terrified me at first, but now I'm feeling it's really liberating that, I've spent so much time enslaved to individual site coordinates. But now we're going to say, no, really, as long as you're in the same H3 pocket, you should be able to figure out who that is. If it's a little 2-part thing, well, then you're in the same pocket. Count on that rather than counting on the exact site locations. At least that's the plan. Okay, add more behavior to HC3. Yeah, we did that. Have some fun. Yeah, we did that. Let's push on. Okay, approach publishability. So progress on eventually getting this little science fiction story out into the world. It's okay because all of this work is establishing a pipeline, a way that, I can say whatever the heck I want to say. I did every other thing in my career kind of on my own weird way. Very few big government grants. Had one, we're on a few. But mostly it was just off in Dave land. Why would publishing be any different? So I made an Ingram Spark account. I've started to climb up the learning curve of trim sizes. That's how big the books are going to be. Covers choices, man, covers incredibly expensive in this publishing on demand thing. The whole thing is super expensive. Okay, well, we already went through printed circuit boards in order to make the tiles, where I was going through revisions of the printed circuit boards like they were water. This is going to be something similar to that. For next time, I want to actually spend some money, buy a block of ISBNs, and figure out a demo book. Not Search Quiet Wake, but something else just to kick the tires. And these are the two possibilities I'm considering. The first one is something like Deterministic Computer Security. You open it to page 1, it says it's impossible, and the rest of it is blank. It's a blank book for you to put notes in. So that's possibility 1 for the demo book. Possibility 2 is a little book of ordinary magic. That's basically slogans that I've accumulated over the years in my slogans file. So each pair of pages would be like a magic trick. You'd say a circumstance when this slogan could be helpful, and then you flip it over and there's blabbing about it, and then you go on to the next one. So we'll see. Deterministic Computer Security would be a lot quicker to try out. A book of ordinary magic would take a lot more work, but it might be more fun going forward. What do you think? Open to other suggestions too. All right, and the goal is to get some kind of first cut PDF. Don't have to submit it yet. That's for outreach. Haven't worked on the symbol this week. Had a discussion about possible rock patterns and stuff, but that's it. Okay, so that's approaching publishability. And finally, announcing the 2022 T2 tile project goal. Here it is. It's been delivered from the upper atmosphere of the administration. Run the ancestor. What does that mean? Well, it means what we're going to do is bootstrap life on the T2 tile grid. And, well, what does that mean? Yeah, in artificial life research, the artificial life community, in particular in the soft artificial life, software-based artificial life, and in the artificial chemistry, the way that one typically proceeds, or kind of the coolest way that people proceed, is first you define a custom physics, a bespoke physics, a set of rules that aren't really about life directly, or at least they're good if they're not. They're more about space and matter and locations and stuff like that. But that bespoke physics has some kind of way that you can represent programming languagey features, some way that you can encode a program, and some way that you can implement an interpreter that will read that program in some way and make it do things. So we make a bespoke physics that has programming language features and also typically has non-deterministic features like mutation, and then you write the ancestor. The ancestor is the primordial program that, where did it come from in real life? Who knows? Billions of years of evolution can do it. And that's the origins of the whole field of origins of life is, where did the ancestor come from? We finesse all that. We say the ancestor came from us. We write the program not in Ulam, but in the bespoke physics with the programming language features. We represent a program that is capable of using whatever bespoke physics we provide to produce a copy of itself, not just to produce, not just to grow it from a seed, but actually to read through its own code and make a copy of that code. Because if there's a mutation, if there's a non-deterministic feature that alters that code in some way, then that alteration can get copied. And if we just sprout from seeds, every one of them goes back to the physics. And that's not what we want here, because then we get evolution. So the goal is on January 3rd, 2023, it's a T2sday, demonstrate an Ulam 5 code base that has some basic structural mechanisms like HC3 and a bunch of other stuff that has a way of representing stuff a programming language, a sequential programming language, at least to some degree, in atoms, in molecules, in sites on the grid. Demonstrate an ancestor program written in that language, demonstrate a seed that can grow out to be the initial Garden of Eden state, to initially put the ancestor down on the grid, to grow an HC3 diamond around it, that whatever it takes to build the first interpreter. All of that can be hard-coded in the Garden of Eden seed, but we only have one of those. We never cast off more seeds of those later, and then demonstrate programmed replication on the T2 grid. That's the project goal for 2022. What do you think? Very pretty cool. All right. So that's the goal for the end of 2022. These are the goals for next time. Break the path to the ancestor down into months, stuff, because there's a lot that needs to happen there. We need the moral equivalent of a virtual machine, the moral equivalent of an instruction set, the moral equivalent of a programming language, all of that stuff. I want to demonstrate HC3 mobile content, squeezing the pockets, and have something in there that can get carried around and be aware of it. Have some kind of first cut book demo and have some fun. Okay, that's it. Sorry it ran a little bit long, but a bunch of stuff. I will continue in the live stream after I get set up to start rendering for the regular episode video, and maybe we can, if anybody wants to stick around, we can look at a couple more little videos. Thank you for stopping in. I hope to see you next time. All right. There. Okay, I'm going to take a couple of minutes to get the recording rendering stuff. Well, actually, I don't know if anybody's here, so oh, there's a few people here. My audio's low. Bummer. I did have a few other things. It's this weird thing, right? Because I do most of the development of all this stuff using MFMS, the simulator, but I don't really want to spend a lot of time showing video of the simulator instead of showing the grid stuff, because the grid stuff is just more essential. It's more real. Uh, um, but I did do a couple of things. So here, I mean, the version of HC3 that we saw in the opening video was all it could deal with was edge of the universe. So the one that I'm going to show you here from the simulator is V14 that is starting to have the ability to deal with obstacles other than the edge of the universe. So I think, is it this one? Yeah. Okay. Right. I mean, in this way, you can see a little bit more. So I've made the max hops much smaller so that let's go full screen. So that it runs faster. And now it's going to go up. It's going to hit the edge of the universe, and there it is. There's the signaling, contact warning from the top. Now, the way it works is the route has a heading that it's picked. So much north, so much southwest, or whatever it is. And so in this case, it ends up hunting back and forth along the edge of the universe like a lion in a cage. There was a case of it bouncing off. That's walls, those white things, and in particular, it's surviving hits on the not just on the points of the diamond, but on the faces of the diamond, and it gets kind of hung up here. But fortunately, it doesn't actually get the deadlock that happened in the video. I'm not sure what caused the deadlock. I'm still not sure what caused it. In the video, I used a four-stage buffer, a four-stage pipeline that you had to wait until 4 layers downstream of you. All right, that's it for that one. I've got another one. Let's take a look at this one, where I throw in some res as well as some obstacles, and its behavior changes quite a bit. But overall the same. It's got its heading, so once it picks its heading, but now if it just sees a res that happens to be in the place it wants to move, you see those little flashes of uh, um, red happening in there, because that's the contact warning saying, hey, there's something in the spot I want to go. I'm going to send it up. But now they look like spikes, because the very next event they're gone, and so the spike that doesn't even necessarily make it all the way up to the root, and all of this just falls out. So gradually I've been removing the amount of res. Oh, there goes. Workstation's overheating a little bit because it's rendering and running OBS and streaming and running the videos. Oh, this is just a video. It's mostly the rendering. Anyway, so you put a little res in the universe, and basically it turns the the brave heading of the thing into a diffusion sort of thing, because it just keeps running into random reses and thinking, oh, I better pick another direction. It still makes progress, and it all works not too badly. I haven't tried putting dreg in there because the respawning, the healing up from damage that HC12 had, the earlier HC3 version 12 had, these don't. And this is, one of these inherent trade-offs, that by having edge sensing and reporting back up, the whole thing has become more welded together. It's making more assumptions about the spatial layout of the whole thing, and therefore running into damage, is less clear exactly how you want to repair yourself, or even if you want to repair yourself. My intention was to have different contact warning signals, to have everything looks clear, to have I see something in the spot I would like to go to, which again is 3 away, so there's still a little bit of time for the root to get the idea and stop sending motions in this direction before I am going to be jammed up. But then the third possibility was to signal damage, to say, By the way, I didn't even get to max hops here before I ran off the edge of the universe, or there's some big pile of wall, or whatever it is. So you really might want to give me priority as far as moving in the other direction, stuff like that. That all remains to be done in the future. Okay, that was the extra little videos that we had. I guess I'll go back to the... All right, I'm going to shut the microphone off, and we'll just text it up here.